All right.
Should we go? All right. So good morning. I have a design proposal to talk about this week. The problem that we're looking at is config distribution status. At a very high level, this means that when someone creates a virtual service or any other Istio config object, there's no feedback on when that's actually being applied to their traffic. This is something that as a human user of Istio, you're not likely to run into because Istio usually tends to distribute config fairly quickly. So if you're creating the virtual service by hand and then by hand sending traffic, you're going to see pretty much what appears to be instantaneous activity or activation. However, when you try to automate over Istio with multiple DevOps use cases, Knative is called out. Also, our own test framework is called out as one of the use cases here. What happens is you end up having to write arbitrary wait statements. And it becomes very difficult to know how long to make the waits. In Knative's use case in particular, they had scenarios where when a cluster was under a lot of load or a mesh was under a lot of load, it would take a long time, maybe up to 15 seconds for config to be distributed. But under scenarios where it's not under load, it would be less than 1 second. And so having variables as far as these waits got very complicated. Currently, they have a workaround, which is highlighted here, where they send sample traffic. They create some sort of a pseudo listener within the virtual service and send sample traffic to it, wait for that sample traffic to start succeeding, and then they allow production traffic onto the virtual service. We really don't want our users to have to go to these kinds of great lengths to leverage Istio at scale from a DevOps environment. And we certainly don't want to have to continue that in our tests, which if you've worked with the, what are they called? The Retry Package, which is under Istio package test. The whole purpose of that package is sending config out in an end-to-end test and then waiting an arbitrary amount of time and running a test against that config. And if it fails, you just try again a few times. This means that our tests will often take a very long time to execute, which does cause developer pain. But more significantly, when we were doing the code MOV work a few months back, we identified that a substantial number of the test flakes that are occurring within our test pipeline, our CI/CD pipeline, were related directly to the retry package. If the cluster was under load, which is common, say, in the lead up time to a release, we would see that config took longer to distribute, and sometimes the timeouts were not set appropriately or were set in such a way that under load, the test would begin to fail at about a 50% rate. This is a critical time for the project, so it's really the worst possible scenario for a CI/CD failure. And we would like to propose a solution, a way that our tests and our users can have visibility into the distribution of config across our system. I want to pause and see if anybody has a question. All right, so I'll skip down towards the proposed solution. We need to come up with an iterative solution for this, because this is a big user pain today in the community. It would be easy to put together a proposal for a very fully fledged Istio feature that could take about 9 months to execute on, and which our users would not really be particularly pleased with the wait time. Additionally, as we saw with Knative, our users are coming up with their own solutions to the problem. And I believe that in a 9-month time frame, if that's how long it takes us to deliver value, the value will be irrelevant by the time it is delivered. So I am proposing that in Istio 1.4, we create a istio-cutl command called wait. It will work very similarly to the way that kubectl wait works. It will essentially, once you change a particular config, you can call istio-cutl wait against that config, and it will watch some data that it's going to get from Galley, and we'll cover that in the implementation area, until that config has been distributed to a certain ratio of Envoy proxies. The ratio will be configurable via command line flag. By default, it's 100%. In some high scale scenarios, 100% is not viable, so the user can sort of control exactly what scenario they're waiting for. The command will either time out if that scenario is never reached or that status is never reached, or it will exit with 0 if the status is reached before the timeout. This allows us to have, again, that use case where we create something that modifies traffic, and then we don't send traffic to leverage that rule or that virtual service that we've created until it is in fact active across our mesh. Any questions so far? All right. I will jump briefly into the architecture of the feature. Currently, we don't really have anything that tracks in a detailed way what version of config is where, or more specifically, that tracks provenance of config from a virtual service in the Kubernetes CRD space into Galley and MCP, and then across to Pilot, and then out to Envoy. However, Pilot does have this really nice feature that is already used in Istio-Cuddle. If you run Istio-Cuddle proxy status, what we're going to be doing behind the scenes is we're hitting a debug endpoint on Pilot that's going to return a list of all the proxies it's aware of, and the most recently or acknowledged nonce. A nonce is part of the XDS and MCP protocols. So the most recently acknowledged nonce for each of those Envoy proxies. I'm proposing that we make those nonces meaningful. Currently, it's a randomly generated number within Pilot, and actually Galley sends its own nonce. Galley's nonce is not related today to Pilot's nonce. Galley's nonce is an incremental in64. So I'm proposing that that Pilot begin to leverage nonces from Galley, simply resending them along in the chain when it sends config. After talking with the networking team, I believe that this would need to be in prefix form. So the Galley nonce would effectively be the prefix of the Pilot nonce being longer. And then internal to Galley, we will track for each of these nonces that we're sending out exactly which versions of each config object was contained in the nonce. So this is sort of a model of the network communication proposal. Pilot or Envoy requests config. The startup, it requests with no nonce. Pilot requests config from Galley. If Galley responds with this particular value, then when Pilot sends that information to the Envoy, you'll see that the same value is maintained, whereas today the same value is not maintained across the communication protocol.
So quick question, essentially to John's point, right? So the mapping is n by n, not one-to-one.
So I've not had a chance to read John's comments yet.
So his comment is essentially an XDS resource can be derived from multiple incoming resources.
That's right. So this does not look at individual resources. This is looking at the config as a whole. And it's a way of bypassing a lot of architectural problems that occur when you do try to do provenance. This virtual service maps to this cluster.
Right. So, but I think the nonces are per collection, right? So essentially, it's the n by n problem still persists at the collection level.
So the nonces are within the communication protocol. The nonces are at the collection level. I'm proposing that each of the collections use the same nonce or nonce prefix, depending on the implementation details.
So from Galley's perspective, it is possible because the new Galley pipeline actually creates snapshots of configuration. You can assign a single number to it, right? Saying that this is the number for the whole snapshot. And at the MCP layer, you can create nonces for individual stream based on that prefix, for example, right? So yes, that works. However, that modeling of the snapshot needs to be preserved at the Pilot side, where Pilot needs to refrain from publishing snapshots until it receives all the collections for that given prefix and.
Oh, I see what you're saying. Yeah, that's an interesting point.
So I think that will be the critical point here, like the problem here.
Okay, that's a good point.
Okay.
I think I'd want more time to like dig into this and think through it. I think that the algorithm can provide us with the ability to build meta nonces that are composed of individual sub-nonces that don't expand forever.
Okay.
I'll need to investigate that.
Okay.
Because yeah, the goal is definitely not to prevent Pilot from sending out config for any period of time or to create some artificial like staging environment or anything along those lines. That would not be, let's see. Yeah, that would not be useful. Any other questions about the protocol changes? All right. So in order to make meaningful nonces out of each version of config, Galley will maintain a Merkle tree in memory that simply is modified at every change that it receives from the config source, which is usually Kubernetes, can also be a file system. So then when a user runs the istio_cuttle wait command, what that will effectively do is reach out to Pilot, all of the pilots, the same way that proxy status does, to get all of the different versions for each of the different Envoy proxies. Then it will compare or send those versions to Galley, asking them, does the version, what did I use up here? I think we had dead beef. Does config version dead beef contain virtual service foo at resource version X or greater? And Pilot can respond with a Boolean value to each of those queries. That process is then run iteratively until the answer is universally true or until the timeout has been achieved. That, I think, covers the meat of the design doc. Are there any questions, comments, concerns?
So we discussed this before, but I just want to, for posterity, bring it up again. So what happens when there's multiple galleys and they reach, they receive configuration in different order and create different snapshots in different order?
That's a great point. The Merkle algorithm that we're going to select is going to have to be order independent, which means that as long as the two galleys converge on a single version of config, they will have the same hashes. It doesn't matter what order they receive the events in. So I have that in a different doc, but it's not linked here, so I won't look it up right now. Effectively, if you have two galleys at version A, and there are two changes coming, and they come in order 1, 2 to one galley, in order 2, 1 to the other galley. Each galley will go from version A to a version that is distinct from one another, called B sub 1 and B sub 2. But then they will converge on one common version C, because their state does converge. So then from the istio_cuttle proxies or istio_cuttle perspective, when we query a galley about the contents of a particular version of config, galley can return a 404, in which case we will resend the request to the next galley in line, which incidentally, as long as we're using Envoy proxy on the control plane, we can actually set that up within the proxy itself and not have that logic need to live in istio_cuttle.
But you won't know, okay.
So the desire is to produce value in the 1.4 timeline. I recognize that istio_cuttle wait does not solve all of the problems we would like solved. Ideally, this data will eventually make its way into the Kubernetes CRD status for better visibility to our customers, but that just did not strike me as something that I could achieve in the next 3 weeks. So this is sort of what I felt like we could accomplish in the time frame we have. Appreciate your thoughts and comments. I'm not looking for approval today by any stretch of the imagination. This has moved way too quickly for that. So if something comes up, please comment in the doc, and I'll try to have all comments addressed within the next week or so.
Well, folks, any other topics? Anything that we should discuss? All right then. See you next session.